Welcome to this lesson on conditional statements. So let's go over some vocabulary first. A conditional statement is a statement with a hypothesis and a conclusion. And a conditional statement will always contain the phrase if, then. The symbolic form for a conditional statement is P arrow Q. So the P is your hypothesis. That's your if. And the Q is your conclusion, the then part of the statement. So an example, if I eat a whole pizza, that is your hypothesis. Then I will be full. That is your conclusion. So there are different types of conditional statements. There are 3 different types that we are going to discuss. The first type is the converse of a conditional statement, and that is where you switch the hypothesis and the conclusion. So you can see these letters are now switched. So an example would be, if I am full, then I ate a whole pizza. And notice I had to reword it a little bit just so it made sense when I read it out loud. So you don't switch them word for word. You want to make sure that it makes sense when you read it. All right, the next type of conditional statement is the inverse of a conditional statement. And this statement negates the hypothesis and the conclusion. So these symbols mean negate or not. Okay, so let's go back to our original. If I eat a whole pizza, then I will be full. So I want to negate both of those. If I don't eat a whole pizza, then I won't be full. Okay, and then the last type of conditional statement is the contrapositive. I'm going to scroll up here so I can write. The contrapositive, this statement switches and negates the hypothesis and the conclusion. So you notice Q is first and then P, so they are switched, and it also has the negation, the not symbols. All right, so an example of this, if I am not full, then I have not eaten a whole pizza. All right, let's try some examples. Write the converse, inverse, and contrapositive of this conditional statement and determine whether the statement is true or false. So the conditional statement is, if a number is even, then it is evenly divisible by 2. Okay, so pause the video and write the 3 different versions now. Okay, so for converse, you should have written, if a number is evenly divisible by 2, then it is even. And that is a true statement. For the inverse, if a number is not even, then it is not evenly divisible by 2. And that is true. Any odd number is going to have a remainder when you divide by 2. And then the contrapositive, if a number is not evenly divisible by 2, then it is not even. And that is true because if a number is even, it will always be divisible by 2. Okay, so you can pause the video and do the practice pages now. Okay, so once you check your practice pages with your teacher, let's go ahead and move on to biconditional statements. So a biconditional statement is a statement using the phrase if and only if. And the abbreviation for that is IFF. So an example, a polygon is a triangle if and only if it has 3 sides. And the symbolic representation looks a lot like a conditional statement. It still has a hypothesis and a conclusion, but the symbol for the if and only if is this 2-way arrow. A biconditional statement is true when the conditional statement and the converse are both true. In the example above, write the conditional statement and its converse. So we're looking at this right here. A polygon is a triangle if and only if it has 3 sides. So we want to change this to a conditional statement. So we could write, if a polygon is a triangle, then it has 3 sides. And that is true. And then the converse, remember, is switching the hypothesis and the conclusion. So I could write, if a polygon has 3 sides, then it is a triangle. And that is also true. So because my conditional statement is true and the converse is true, that means that the biconditional statement is true. All right, so let's try some examples. Number 1, rewrite the statement as a biconditional statement. All quadrilaterals have 4 sides. So when you're going back and forth from conditional to biconditional, you may have to add a few words in just so it makes sense when you read it. So for this one, I could write, a shape is a quadrilateral if and only if, or you can use the abbreviation, it has 4 sides. Number 2, determine if the biconditional statement is true or false, and if it is false, give a counterexample. An angle is acute if and only if it is 45 degrees. Pause the video and answer that now. All right, you should have said this is a false. And a counterexample could be an angle that is 30 degrees. That's still acute, but it's not 45. Number 3, rewrite the statement as a biconditional statement. Is it true or false? Pause the video and answer that now. All right, so you could have written, a shape is a rectangle, and I'm going to use the abbreviation here, if and only if it has 4 right angles. And that is true. All right, number 4, create your own true biconditional statement. Pause the video and try that now. Okay, so your answers could have varied on that one, but just make sure that your statement has the phrase if and only if. All right, now you can complete the other practice pages and check with your teacher.